Welcome to podcast number 8, which are properties of salt solutions, where hopefully we can take a little bit of a break from the math that we've seen in this chapter so far, and we can do a little conceptualizing about whether a salt solution is going to be acidic, basic, or neutral. So when we have a solution of a salt, the salt itself can either be acidic, basic, or neutral. Right, and a salt is basically just an ionic compound, right, that has a cation that is not an H+, so it's usually going to be a metal, although it could be the ammonium cation, and an anion that isn't OH-, right, and those are usually things from group 16 or 17. And so we are going to determine whether our salts are going to be acidic, basic, or neutral by looking at 3 different factors. Number 1, we're going to look at the cation. All right, the cation is either going to be acidic or neutral. It's only going to be one of those 2. Then we are going to look at the anion, and the anion is going to be either basic or neutral. Notice that an anion is never going to be acidic. And then we're going to add those 2 things together. So we're going to take the cation and we're going to add it to the anion, and we're going to see, right, what is the effect? Is it going to be acidic, basic, or neutral overall? Right, so that's what we're going to care about overall. Let's start by looking at our cations and determining whether they are going to be acids or spectators, right? And when they're spectators, we're going to say that they are neutral. And so most of our cations are acidic, right? This is going to be one of those topics where you really are just going to have to memorize some stuff. All right, now don't worry about the fact that it says that this will change the pH by more than 5, right? Or anything like that. We don't have to memorize anything along those lines. What we need to do, though, is we need to memorize which things are acidic and which ones are neutral. Okay, it says most cations are acidic. All right, and so it's probably easiest to memorize the exceptions. All right, our exceptions are, right, group 1, which are our alkali metals, right? Those are things like lithium, sodium, potassium, rubidium, and so on. And then the heavier alkaline earth metals. So group 2, calcium and below, right? And so I show that as being strontium, barium, calcium, right? Radium, right? So not magnesium and beryllium. These are acidic. Okay, so what you need to know is like group 1 are spectator neutral, and then group 2, calcium and below, are going to be neutral. All others are acidic. Now let's take a look at anions. Anions are a little bit more difficult to kind of memorize, but they can only be either a base or a spectator ion. Okay, so again, most of our anions are going to be weak bases. Right? However, we have some exceptions. All right, now, as I said, these might be a little bit more confusing than the exceptions for our cations. However, if you took my advice earlier and memorized the 7 strong acids, well, any anion of those 7 strong acids are going to be spectators, neutral. All right, so, right, if you think like HCl, strong acid. So the anion of that is the chloride anion. This would be neutral in this case. So all you have to do is memorize 7 of these exceptions, right? And they're from the 7 strong acids that I'm hoping that you've already memorized. Now we're going to take the cation and the anion and combine them together and see what we're going to get. So if you have, say, an acidic cation and a neutral anion, this would be acidic. If you have a neutral cation and a basic anion, right? Neutral plus basic is basic. If it's neutral plus neutral, then the overall thing is going to be neutral. All right, now lastly, if you have acidic plus basic, then we have to follow these rules on this slide. We're going to compare the Ka of the acidic part and the Kb of the basic anion part. Whichever one of those numbers is bigger is going to tell us whether it's acidic or basic. So if the Ka is bigger, then it is acidic. If the Kb is bigger, then it is basic. Right, so I've got my ammonium fluoride there is my top one. The Ka for the ammonium cation is 5.6 times 10 to the minus 10th. The Kb for the fluoride anion is 1.4 times 10 to the minus 11th. 5.6 times 10 to the minus 10th is bigger than 1.4 times 10 to the minus 11th. So the Ka is bigger, so it's acidic. Right, so that's all we have to do in those cases. If you have, this is your case. I will give you the Ka and the Kb, and all you're going to have to do is compare those values. Here we have sample problem 18-9, where we're going to decide whether these salt solutions are going to be acidic, basic, or neutral. And I want to point out that I've already put in whether things are acidic, right, neutral, being spectators, or basic, and stuff like that. You need to go back and make sure that you can also do these things. We're going to talk about why they are the cases that they are for some of them, but make sure that you can do that part on your own in case these sorts of problems come up. So it says state whether 1 molar solutions of the following salts in water would be acidic, basic, or neutral. So we've got iron 3 chloride there. All right, well, we're going to separate these out into their cations and anions first. So the cation part is the iron 3, right? So that's my cation. And so we notice that this is not group 1 or group 2 calcium and below. So acidic. Right, then we're going to say, okay, the other part of this, the anion part, are chlorides. It doesn't matter how many there are, that doesn't factor into this whatsoever. So this is the anion of a strong acid. So it is neutral, right, or a spectator there. All right, so you have acid plus neutral. That's going to be acidic overall. All right, now let's go down to say something like C. All right, so again, C, we have the cation part is the NH4 plus, right? That is going to be, right, the ammonium cation, right? That is not in group 1. It is not group 2, calcium or below, so it's got to be acidic. Then I look and I go over to the anion part, right, the NO2. All right, so I'm going to pair it up, and I'm going to say HNO2 is a weak acid. It's not a strong acid. So NO2 is basic. All right, hopefully we see how that works. If I pair it up with H's and it becomes a strong acid, it's neutral. If I pair it up with H's and it becomes a weak acid, then it is basic. All right, so we've got acidic plus basic equals, I don't know, we're going to have to look up the Ka and the Kb. And that stuff's given to us on the next slide. So make sure that you can go through and do these, and then we'll see what we do on the next slide there. See again for like A, that was easy, right? Acid plus spectator. We got acidic. For part B, neutral, neutral. We're going to get neutral. Right? For part C, we had a Ka and a Kb because we had an acid plus a base. And so we had to look up the Ka for that versus the Kb and just determine which one of those numbers is bigger than the other one. Again, I get students that'll miss those ones a lot. It is not that difficult. Just know if the Ka, then the acid is bigger, then it's acidic. If the Kb, then the base is bigger, then it's basic. All right, make sure that you can do those. All right, next we're going to do one more sample problem. It's going to tie a lot of this information, not only from this podcast, but many of the others that we've gone over so far. And so it might not fit into this podcast exactly, but we're putting it into this podcast. Just take note of that if you need to go back and kind of double check that in your notes whenever you're doing stuff later, studying. Here we have a sample problem, which is an in-depth one. And this is the type of problem that I really do like on exams, especially if you're going to be taking any multiple choice type exams or any short answer, right? This is the sort of thing that I really like. It says that we have 6 beakers. All right, so we've got our 6 beakers. They're labeled A through F, and all of them have 100 mils, and they all have 0.1 molar solutions. So the first thing is we want to look and determine, right, which one of these are going to be strong acids, which one of them are going to be weak acids, strong bases, weak bases, and so on, right? Because if we know all of those things, then we know if we need to look up any Kas or Kbs and stuff as well. All right, so if we look like beaker A, right, is going to be a strong acid. Right? Beaker B is a weak acid. C, strong base. D, strong base. E, all right, we have NH4 plus. All right, so that's going to be a salt. So that's going to be a weak acid. The chloride is going to be neutral. So the overall thing is going to be a weak acid. All right, and then we have our C2H5 NH2, and that's going to be a weak base because there's an amine in that molecule. All right, so we've determined, right, what each one of those are, and then we can say, okay, I might need to be able to look up and see what the Ka or the Kbs are of certain things. So here we have those also worked out, and I've added in the Kas and now the Kb for our amine. Okay, so next off is A has the pH in beaker A is, all right, less than, greater than, equal to, more information, of the pH in beaker B? All right, well, we have to look. Beaker A is a strong acid, and beaker B is a weak acid. All right, now they are both 0.1 molar solutions. And so the strong acid is going to ionize completely. The weak acid will ionize only partially. So one that ionizes completely is going to be more acidic. All right, so it is more acidic. So beaker A is going to be more acidic. And so the pH in it, right, would be less than the pH in beaker B. Let's do a couple more of these, and then I'm going to leave the rest of them up to you to do on your own, even though they're written out. Let's do B and C on here, and I'll leave you up to D to read through on your own. B says the pH in beaker C versus the pH in beaker D. Okay, notice that if you were to go back and look at them, both beakers have strong bases, right? But the one in beaker D, right, beaker D was barium hydroxide. And the barium hydroxide had 2 hydroxides that are going to be given off. So even though both solutions are 0.1 molar, it's actually going to be 0.2 molar in hydroxide, whereas the sodium hydroxide one is going to be only the 0.1 molar. All right, so the beaker D, right, is going to be more basic because it's going to give off more hydroxides. All right, and so if it's more basic, then its pH is going to be higher. So the pH in beaker C is actually going to be lower or less than that pH in the beaker D. All right, next up we're going to look at the percent ionization in A versus C. All right, well, A was a strong acid, so it's going to ionize 100%. And beaker C was a strong base, and it's going to ionize 100%. So that's all we need to know that they are going to be equal to each other. All right, again, be able to do D and then be able to think outside the box on what else could I possibly ask you about some of these other ones, because again, I like these sorts of problems. All right, so that ends looking at salt solutions. Now we're going to turn our attention for a long time to the concept of something that we're going to call buffers. We're going to start that in our next podcast.